So, yeah, so there is a lecture number 2 for this workshop, and it is the most important lecture of the workshop because it includes sizing procedure and design methodology for indoor remotely controlled airship. So, before start the session, I would like to give a brief introduction of me. I have completed my BTech with Aeronautical Engineering from Dr. APJ Abdul Kalam Technical University, Lucknow. And I am glad to share that I was the university topper in my branch. And in my after my third year, I completed an industrial training at ADRD DRDO Agra, which deals with aerostats and LTA systems. So there I worked on a topic of conceptual design of solar powered hybrid airship. And after that, in my seventh semester, I got an in my eighth semester, I got an opportunity to apply for a research internship in IITB, and for that, I selected for the research internship award for a semester. So in that internship, I worked on the system, which is a phase change based LTA system. And I also completed 10 NPTEL courses in which I am the topper in 5 of them. And I also published 5 research papers and presented successfully in international conferences, among which one of which is selected for the best paper prize in ICOST International Conference on Science, Technology and Engineering in Australia, and one of which paper is related with the LTA system. And currently I am working as a project research assistant in LTA Systems Lab, IIT Bombay. So right now I am in Agra, and I am here presenting my PPT because I am working from home due to COVID. So there is a beautiful picture from the city of Taj. So there is a Taj Mahal from Agra. Now I would like to start my presentation with the motivation of this lecture. So the motivation for sizing of airship it starts with the like there are as you've seen in the previous lecture, there are so many airships outdoor and rigid, semi-rigid on the basis of their structure. So I will not give the information or sizing procedure for those airships. I will only focus only on the airship which is indoor and also remotely controlled. So can someone guess and tell me why I am insisting on indoor airship? Can someone unmute yourself and tell me?
I think it is a indoor type of airship which is fly only in home.
Yeah, indoor money. It will be fly inside the room or hall. But why it will be indoor? Why not outdoor or any other airship? So what is the reason behind it?
I think it is a small type of airship which is only flying indoor, and it is toy, I think.
Not a toy. Actually, it can be big one as per the availability of the room or hall size. But indoor, in the sense, there will be less variation of the atmospheric wind and other data, and this can be controllable. Like inside a room or inside a hall, the environment of the hall and room will be controllable, and we can control our airship. So that's why I'm insisting towards only on the indoor airship, which is remotely controlled. So we can control it. Okay. So further, we will not look like a very fancy shape and very fantastical, artistical shape for the airship. We will take a shape which is a shape of the actual airship. So as you've seen in the previous lecture, there are you have shown some actual airship which is flying. So can you let me know what type of airship, what type of shape you have seen? of the airship?
It is basically egg type shape.
Yeah, oval, egg type shape. Yeah. So it is called as a ellipsoid shape. So there are several shapes available for which, but actual shape is a ellipsoidal shape, which is very simple shape. So that's why I would recommend you that please take only the actual airship shape, not take any fancy shape or any other shape which is complex in designing and any other. So can someone let me know what is meant by lenticular shape, which is written over here? So lenticular shape is basically a shape similar to a UFO. Like when we see in a top view, it will be a circular one, and we when we see in a side view, it will be a ellipsoidal. So we will not look on any of the fancy shape, lenticular, and other variation of the shapes. We'll only focus on the very simple actual shape of airship which we have seen, like a ellipsoid. Okay. Then when we make some vehicle or any system, any aerial system, so it should be able to lift some payload. Okay, as sir mentioned in the previous slide, the payload. So payload should be there because we are designing or we are sizing any system. So it can lift a dedicated payload which we have, which we would like to carry on an airship. So it should have some capacity to lift that payload, because the main purpose of the airship is to lift. If it is for a surveillance or photography purpose, so it should include the payload as a camera. So if in the gondola there will be no passenger, there will be camera attached to the gondola, and it can be able to take photographs and videography and surveillance over a specific location. So that's why it should have some uh, sufficient amount of payload capacity. Then, as we are talking about the airship, so there is a main difference between airship and aerostat. So aerostat is only fixed at a location, and only it is only stable only on the mercy of the wind. But in case of airship, we are talking about some kind of control. So in case of an airship, we should have three-axis control of this airship, because as we are flying it indoor, so indoor room or indoor hall where we are flying, where we will fly this airship. So that's why we will be having three-axis control for this, for pitching and for side movements and for yawing and rolling. So that's why it should have these axis control. So before starting, I would like to define a problem, like what we are going to do and what we are interested to do it in a manner. So for designing or sizing of an airship, for remotely controlled airship specifically, there is no a systematic approach is available in an open literature. So so that's why in the name of this workshop, like in the type of this PPT, we will deliver to you a sizing procedure for this airship. So there is no systematic approach available. So we will provide you the procedure to design this airship. Okay. So we will let you know the design and fabrication methodology used for indoor remotely controlled airship, and it will be a non-rigid, because we would like to fold it and put it in a bag and we can carry it. So it will not be having any structural support. As you have seen the types of airship on the basis of structure, there will be three types. We are focusing only on the non-rigid. So non-rigid, there will be envelope and there will be attachments of the payload, and there will be very minimum equipments to be to be attached to its envelope. Okay. Then it should have a payload capacity, decent payload capacity up to 250 grams. As we talk in case of a camera or in case of a surveillance or photography purposes. So The battery and the camera can weigh up to 250 grams. A decent weight can weigh up to 250 grams. So the payload capacity of this airship should be around 250 grams. Okay. Then I would suggest that it should be a electrically powered one. Can someone tell me why I recommend electrically powered? You can unmute yourself. And can someone tell me what type of propulsion system we can use in an airship?
Sir, can we use a small turboprop? Small?
Yeah, but for an indoor airship, turboprop engine is not a decent one. Like we cannot use for a turboprop. And as you know, airship is a slowly flying vehicle. And in case of a indoor airship, there will be a limited space available to fly. So
Sir,
as turbo, yes.
sir, sir, for the indoor, we can use electrical power motor.
Yeah, I am recommending that please use electrically powered engines or motors. So why I am recommending this? Can you guess?
lesser in weight.
Okay, so can you let me know the other type of propulsion system other than the electrically one?
Solar. I think.
Okay, but indoor, in case of an indoor airship, how will you take sun inside the room or hall?
Okay, indoor.
For lift generation, we can use gases inside the envelope.
Yes, but propulsion system on an airship, we don't use it for the lift generation mainly. We use it for the forward motion, or in case if we want it to for the upward, so we can put it a thrust vectoring and we can get a lift in a upward direction. But generally, with the help of propulsion system, we would like to get it on LT system only for the forward motion. So we get lift by the buoyancy and with the help of a lifting gas. So electrically powered, actually, I'm suggesting for uh, if we use any other like piston engine can be the alternative option for the small sized airship. But in case of piston engine, there will be difficulty in starting of those engines. And in case of electrically powered motors, we can start and restart again. We can stop when we want, when we can start when we want. So this will give us decent control over its controllability. Okay, so we can control the electrically motor very efficiently. So that's why I would recommend that we can use the electrically powered motors on our airship as the as the case of propulsion system. So we can get a required thrust with the help of electrical motors. Next, I would like to say that length of the indoor airship, it should be less than 4 meter. Can someone guess why it is less than 4 meters?
It will be flying inside the room, so length should be small.
Yeah. General hull we can make as large as airship, but it should fly inside the hull or inside the room. Correct.
Yes.
That's why we should keep the length to be sufficient that it can fly and it can turn around in a hull and it can fly up to a decent direct forward motion. So that's why on the basis of our prior history or prior knowledge, like we have built some RC airships. So on the basis of that, the length should not be more than 4 meters. Next, the testing arena for this kind of airship can be a hall or any classroom. So, okay. Next, I would like to showcase some design requirements for this airship. So, first requirement that, as I mentioned, that it should be portable. So, the airship which you are going to size or design, so it should be portable one, because I already mentioned that it should be a non-rigid airship. So in case of a non-rigid airship, we can fold it and put it in a box of dimension as mentioned: 68 centimeter of length, 49 centimeter of breadth, and 28 centimeter of height. So can someone tell me why these dimensions are chosen?
Because they will be sufficient enough to carry 250 grams of weight.
Uh, Sufficient enough to carry?
Carry the payload of 250 grams.
No, this is not the dimension of the airship. This is the dimension of the box in which we can carry our airship in a fold. Like when we fold it and we can put it in a box. So this is the dimensions of the box. So why we need this much of dimensions as the height, length, and breadth considered? Like when we talk about the non-rigid airship, there will be an envelope, correct? So when we fold this envelope, it can be fit into a very small box. So why we need this much of dimensions? So as
Other
you
equipment
see,
also there.
yeah, other equipments are also available there. So we need to carry them along with the envelope. An envelope will not play a role, correct? Envelope only needed to hold the LTA gas, like lifting gas, inside the envelope. So other than the envelope, there will be some other equipments which has to be carried along with the envelope. So that's why this is the dimensions of a very available suitcase or any other box. So that's why we have chosen this dimensions of the box. The next requirement is it can be assemblable in very quick time. Correct. So when you have to fly the airship, you don't have to take so much of time in the assembly of the airship. Like you have to fill the envelope and you have to mount all the equipment on the airship. So all these things should be done in less than 60 minutes. Like within an hour, you are able to fly your airship or you can showcase your work. It should not take around 4 to 5 hours. So it will get lose motivation, like excitement and motivation you will be lose. Like audience will get like 4 to 5 hours only in the assembly of the vehicle. So that's why it is another main requirements, like it will be assemblable in a very quick manner. Another point is it should be maneuverable. So in the terms of maneuverable, it should uh, perform the spot turn. Can someone let me know what is meant by spot turn?
Like it should not require any turning radius. It should turn on the spot.
Yeah, very good. So turning radius should be 0. So can we get spot turn in case of a fixed wing aircraft?
No, not possible. Only in VTOLs.
Yeah, so yeah, in case of a VTOL when it is hovering, then we can get, but in case of a normal conventional fixed wing aircraft, we cannot get spot turn. So why spot turn is a requirement in this kind of airship, in this kind of indoor remotely controlled airship?
As we'll have less space indoor, it will be very feasible for us to get a spot turn
Yeah, very good.
possibility.
So as the hall or the classroom will have the corners, and we will having the limited space available to us for airship fly. So that's why it should be able to perform the spot turn, correct? And it should be able to move in all 6 directions, like as I mentioned, for it should have 3 axis control, so it can be able to move in all the 6 directions. Okay. Uh, so arena, typical demo arena can be a auditorium or hall, and payload can be a desirable payload. It can be sensor or any camera. So volume for the airship, as you know, uh, have I hope you know the gas for the lifting gas. The mainly 2 gases are available, as it mentioned here in the name of LTA gas. There are 2 gases available: hydrogen and helium. Hydrogen is easily available, and helium is very costly and not easily available to us. So volume should be able, we should be able to fill our envelope with only 1/4 cylinder of the LTA gas. So around 7 cubic meter available to us in the cylinder, and we cannot get all the 7 cubic meter. There will be some, we cannot get out all the 7 cubic meter of the gas. So we should have volume about 1/4 of the cylinder of LTA gas in every filling. Like if we have to fly and we have to fill the airship after one fly or one showcasing to another one, so we have to uh, remove the air, remove the gas from the envelope, and we have to fold it. Then again in the second try we have to fill the LTA gas, then again. So it should be able to have 1/4 of the cylinder at a time. It should not be large enough to get the whole cylinder in a one fly only. Correct. So it will be very cost, because when we create a large airship, it will get higher lifting gas and it will add up to the cost of the gas. Endurance for this airship should be at least 15 minutes, minimum of 15 minutes. Because when we fly any aerial vehicle, so we test out all the control surfaces and all the equipments, avionics. So in that there will be a time consuming. So the battery will get uh, discharged in that also. So around 5 minutes will take for all the testing of the systems, and we will get 10 minutes for fly. Okay, after 10 minutes it will be discharged. So we will have to change the battery. So endurance should be enough to entertain or to showcase our work. It should not be like 2 or 3 minutes, because audience will get less excited towards it, because after 2 or 3 minutes we will have to change the battery again. So it should have a sufficient endurance of 15 minutes. Lifting gas can be hydrogen or helium, and there are many other gases, but these are the main two. In this, hydrogen is available, readily available and cheap, and helium is very costly and not easily available. Shape, as I discussed earlier, it should be a real airship shape, like the actual one, for the simplicity. Okay, can I go ahead? If someone has doubt, you can ask here.
No doubts.
Oh,
No doubt.
correct. So let's move up to the aerostatics, the main conceptual topic of this sizing. So aerostatics deal with the buoyancy. So we get buoyant force with the help of aerostatics, with the help of lifting gas. So there are two types of lift in case of a lighter than air system. So there will be a gross lift and there will be a net lift. So what is meant by gross lift? Gross lift is simply the multiplication of ambient air density into the envelope volume. So by doing the multiplication of these two, we will get the gross lift in kg. If you would like to have in terms of newtons, so you will have to multiply it with the gravitational acceleration g. So as we are not multiplying it with g, so we will get gross lift in kgs. Okay. Then we will get the net lift from the gross lift. When we deduct or subtract the gas weight, so as we fill the gas inside the envelope, so gas also has some weight. So we will have to minus that weight from the gross lift. So after that, we will be able to get the net lift of the system. So this net lift is available to us to carry the other systems weight, like weight of the envelope and any other equipment weight, and also the payload, which is a desirable one. So with net lift, we counter all the weights. So can you let me know some of the factors which are affecting net lift? Yeah, tell me. So there are several factors. Yeah, someone wants to speak.
Atmospheric conditions.
Yeah, atmospheric conditions puts factor puts so many effects on the net lift. So there are some of the factors which I have taken into the consideration, like internal pressure of the envelope and the superheat when we take airship from the sunlight to shadow one, and from shadow one to the sunlight. So there will be a superheat, and Because of the humidity, there will be loss in the net lift, and because of the gas purity, there is also the loss in the net lift. Because we don't get the gas 100% pure, that's why we get the loss in the net lift. So these are the four uh, factors which affects the net lift. So there is two important points, which is center of buoyancy and center of gravity. So in case of lighter than air system, or in case of airship, center of buoyancy generally lie above the center of gravity because of the gondola. In case of a non-rigid airship, because gondola consists of a weight, so CG mainly lie below the center of buoyancy. Then can someone let me know this term static heaviness, as LTA system is a part of your course, of your syllabus? Can someone tell me the term static heaviness? What is mean by this? Basically, what we do when we have to lift the payload, or when we have to lift the weight, so we have to generate adequate amount of lift to carry that payload, to lift that payload. Okay, so what we do, lift minus the system weight, like the self weight, it should be equal to payload in an ideal case. But when we get the system weight is heavier, because we would like to, in case of any failure, in case of any misbehaving of the system, it should not go away in the sky, it should be recoverable. So that's why we make it a little heavy. So that's why system weight is a little heavy, so it is known as the term is known as the static heaviness. Okay, so now I will come to the point, come to the methodology of this sizing. So there is a sizing procedure which goes in a way. Firstly, we will decide, or we will estimate the dimensions of the envelope, and then we choose a shape for the envelope. After choosing the shape, we calculate its dimensions, and after doing this all these things, then we select a material for the envelope and all these things. Then we put a payload, or decide a payload, and then we move to the fabrication of the vehicle. Then there is a complete design methodology for this system. So it is a detailed one. In this, the main focus is, can you see my mouse? So the main focus is here. Lift minus total weight should be equals to payload. But for obtain this value, we start our methodology, or our start design, with the initial estimate of envelope volume. So volume is decided as we are taking the actual shape of the airship, it is the ellipsoid one. So firstly, we assume a length of the airship. On the basis of that length, we initially estimate envelope volume, correct? So can someone tell me how can we guess the envelope length? Because it is an iterative approach, so we will have to assume some parameter and start calculations. After doing the calculations, we will get that we are getting our values or not. If not, then we reiterate the process, and if we get our desired result, then we stop the process. So in case of airship design, we start our, in case of remotely indoor airship, we start our calculation by guessing the envelope length. So as I mentioned in the earlier slide, the length should be less than 4 meter. So we can start our calculations with 4 meters, 3 meters, 2 meters, 3.5, 2.5. So by doing this, we can estimate initial estimation of the envelope volume, the first box in the design methodology. Then the second one is to select the shape of the envelope. As we have selected the actual shape, the ellipsoid shape, so after selecting the shape, we can decide the geometry. Correct. We can obtain the dimensions of our envelope. After obtaining the volume and the shape, we can actually obtain the surface area for the for our vehicle, for our airship. After obtaining the surface area, we can actually get the envelope material, because the surface area is made, the surface which is of the envelope is from the envelope material. So by using the envelope material properties, we can get the envelope weight. So there is a first point of weight which is coming here. Then after doing the surface area calculations, we can estimate, we can do the tail sizing. So tail here referring to the fins which we have seen in the airship at the rear side. So the fins, it is mentioned here is tail sizing. So by doing the tail sizing, we get the parameters, or we get the dimensions of the tail, by using which we can get the weight of the tail. Correct. After that, CAD model is a uh, arbitrary one. Like one can, it is optional. So one can create a CAD geometry of your model, and one cannot. But creating a CAD model is very helpful in doing some conceptual design. Okay, so in conceptual design, when we create some model, we can get some of the aerodynamic characteristics of parameters by using the CAD model only. So can someone let me know, like which software we can use for CAD geometry of this airship?
SolidWorks.
Okay, SolidWorks is a very detailed one. We can create the model on the SolidWorks, but on SolidWorks, it's a mainly it is a software for mechanical engineering or mechanical parts. So for aerospace parts, can someone let me know other CAD tools by which we can?
Sir, CATIA V5.
Yeah, CATIA V5 is a very detailed one in which we can create a very detailed geometry of the mechanical parts. We can also create our geometry, but it is not very specific to the aerospace applications. Correct. So, do you know about a software OpenVSP?
No, sir.
No one in the
No.
audience?
Yes, yes.
Okay. You know about the OpenVSP.
Yes.
Okay. So OpenVSP is an open source software in which it is aerospace specific tool. Like we can create our geometry in very less time. Correct. So, and it also helps, and it also provide us the wetted area estimations and also the parasite drag coefficient very easily. So that's why I would suggest you can create a CAD model geometry of your model on OpenVSP. So after creating the CAD model, we can compute our drag and power estimations. So drag and power estimations will be available with the CAD model, and we can alternatively get it by the alternative formulas available in the literature. After that, as it is a electrically powered airship, so we have to select the electric motor according to our requirements, like drag. By doing the drag calculation, we get the thrust value, and by using that thrust requirement, we can select out our electric motor. And after selecting the electric motor, we can get the weight of the electric motor and all the related parts like propellers and all these things. After that, we will have to put some avionics on the airship. Correct. As it is a remotely controlled airship, so it will be having a receiver, and it will be having a card on the airship for receiving the message and receiving the command, and also some wires on it. So that's why avionics to be selected as per our requirement, and it will also add up to some of the weight. So it will also include the avionics weight. So you will be having 4 weights here: envelope weight, tail weight, electric motor, you can say it as propulsion system weight, and the last is the avionics weight. And by the volume available, you can estimate your net lift. So by doing the net lift minus the total system weight, if you get it equals to your payload, as you mentioned as 250 gram, it is equal to your payload, then we'll check it is it uh, requirement is fulfilled or not. If not, then we change the length of the envelope, then we obtain the second volume. Then after obtaining the second envelope volume, we proceed with the whole process again. So when we get the requirements, or our requirements is fulfilled, we stop the process and we get our desired result. So anyone having doubts in this methodology? Because yeah,
I have doubts.
yes,
How will we compute drag and power, like drag and power computation on what software?
Yeah, in drag and power computation, you can use OpenVSP for calculation of CD naught.
Yes.
So when you create your geometry on the OpenVSP, you can easily estimate your CD naught value by providing the parameters, like surrounding parameters. It will ask you
Yes.
some operating parameters. Then after providing it, you can get CD naught value available to you. By using that CD naught value, you can easily calculate your drag, correct?
Yes. Yes.
And after calculating the drag, you are be able to get the thrust required, which is nothing but the drag. So by using the thrust into the velocity in which you would like to fly, so by doing the T into V, you will get the power requirements, correct?
Yes.
So in this way, we can calculate the drag and the power computation. Yeah, any other doubt?
And we'll need to use a flight computer, right? In the avionics section.
In the avionics section, you have to use RC, like remote and receiver and transmitter. So you have to put the receiver onto the airship.
Okay. Yes.
So
Yes.
in avionics section, you will have to put the receiver and the wires and some other things on the airship. So you will have to count it in the avionics section.
So Naman, I would like to add something here.
Yes.
For drag estimation, it is not necessary to really use a software, because first cut estimate can be obtained by using some formulae in literature, which we will explain. So in a one-day workshop, obviously we cannot use CAD software or a CFD software or even OpenVSP. So today we will teach you how to get an estimate using some simple equations available in literature. But yes, later on, you can, when you actually do the work, you can use the CAD software. Okay, second point was regarding the flight controller. So this is a simple remotely controlled airship, not something which is autonomous or which has got any other feature. Therefore, there is no need to put a flight controller, because 250 grams is the maximum payload available to you. And a flight controller is not really essential, because you can fly it by remote control. So as Naman said, all you need is, on board you can have a small receiver which can be used to communicate with the electrical motors and just give them the required thrust. So we are looking at a very simple airship. Of course, one can go for further complications, but remember, everything is going to cost money, and also it will have weight.
Yeah, so envelope sizing and fabrication, we will take a look on the envelope first, because we will have to size our envelope first. So envelope shape, there are some consideration to be considered for the geometry of the envelope. So the best shape for a lighter than air system vehicle is spherical. Can someone tell me why spherical is needed? Like, why is the best shape? Spherical shape provides us the least surface area per unit volume, as it mentioned in the next point. So spherical, but it provides a huge amount of drag. So that's why spherical is the best shape from the geometrical consideration, but from the aerodynamic consideration, it is not. It is the worst shape, because it creates a lots of drag. And as you've seen the advertisement balloon outside any shop or any in the fair, so it produces a lot of oscillation in the air, correct? So that's why we do not use the spherical one. But from the drag consideration, the best shape is from the high L by D ratio. L by D is not the lift to drag ratio here, it is the length to diameter, length of the airship to the diameter of the airship. So it should be high. So there is a range in which this value can be located. So this range for this type of airship is from 3 to 5. So what it gives, the disadvantage of this shape, it gives the higher surface area per unit volume. Higher surface area which will leads to the higher envelope weight. Because surface area increases, then the material will increase, surface material, then envelope weight will going to increase. And it will it will require the less stabilizer area. Why it needs the less stabilizer area? Because the fin, stabilizer means fins here. So in case of a higher L by D shape, so we will be having enough moment arm. So we will be having requirement of less stabilizer area. So less stabilizer area means less tail weight. So on one hand, we will be having the higher surface area of the envelope. On the other hand, we will be having the less stabilizer area means less tail weight. So we will have to take some sensitivity study here, like what type of shape we will have to chosen here. So the best shape for this, it will be a compromise in between two shapes. Like with the geometry consideration, there will be a spherical, which is the best shape. From the drag consideration, there will be the shape which having the high length to diameter ratio. So the compromise between the two will give a our shape. So there is a first cut volume estimate, and we start our our process with the initial estimate of volume. So there is a trend line drawn with the actual airship, like payload versus volume. So what payload they carry and what is the volume of that airship. So you can see here there are some airship companies which they have built their airship and flown. So in the green circle we have also shown here our airships which designed and fabricated in LTL lab. So there is also typically follow the same trend line. So there is a procedure to obtain the first cut volume. It is not the very specific, but we can get we can get the initial estimate of the volume from this trend line. After that, you will be having several choices for the envelope geometry. As I have mentioned that envelope shape, we will choose the actual airship shape, which is the ellipsoid one. But in the ellipsoid one, as we have seen the actual airship, there is also several shapes available to us, in which the first shape is NPL shape. It is available from the National Physics Laboratory from UK. So it is nothing but the combination of two ellipsoid. So there are two ellipse equations available here, and we are getting the semi-major axis of the two airship is of the ratio of √2. So there is a combination of two ellipsoids, and the another one is the GNVR shape, which is given by Professor GNV Rao from ISC Bangalore. So this containing these three types of shapes. In the front portion, it will be an ellipse. In the mid portion, there will be an arc of the circle, and in the rear portion, it will be a parabola. And there is another shape which is available is Johan. So it is from China. So they also have created this shape, and they have fabricated and flown this airship with this shape. So the parameters of this shape also available and coordinates available to us. So we can also create this. But as simplicity, we will go with the NPL shape, which is the very simple one. So there will be two two ellipsoids which are joined together at the same dia. Okay. So front portion is ellipse and the rear portion is also ellipse. And when we convert all the parameters with the diameter only, so it has the this distance is 1.664d and this distance is 2.336d. So there is another elaboration of that shape. So you can see the length of the front half portion to the length of the front portion, the ratio of these two will be √2. And the overall length to diameter ratio is 4. When you combine these two lengths of the front portion and length of the aft portion, 1.664 plus 2.336, it will combine to 4. So the total length of the airship to the diameter will give you the ratio of 4, which is come in the range. As I mentioned, the range of the L by D will be 3 to 5. So we are having 4 for this shape. So we can use this shape for our airship. So there are some envelope materials available to use. So the features or characteristics given for envelope material is, one of the main feature is GSM. So we calculate the weight, or we get the properties of the envelope material in GSM. GSM stands for gram per square meter. So it should be low as possible, because it will add up to the weight of the envelope. And then permeability of the to helium and hydrogen, like permeability to the LTA gas, lifting gas, it should be low. When we fill it, it should be able to hold the gas inside the envelope. It should not leak. So permeability as low as possible, and it should have the higher tear strength. It should not torn away by some hit or any internal pressure. And it should be flexible enough to fold and then filled up, then fold, then filled up, and it can be carried because we have to carry it, so it should be flexible in nature. And the most important feature of the envelope material, it should be sealable, because we have to create an envelope with it. So when we create an envelope, we will have to attach edges. So we will have to petals of the airship, and we will have to join them together. So it should be sealable. So these are the main characteristics of the envelope material. So there are some promising candidates for the envelope material. For the one is metallized polymer. So it comes in a range of 65 GSM to 150 GSM, 65 grams per square meter to 150 gram per square meter. So it is a metallized polymer, and we can also use the PVC coated nylon. Nylon we can get in a 120 GSM, but when we coat with PVC, so it can weigh up to 180 GSM. Then we can use only PVC, which is a slightly higher weight than the PVC coated nylon and metallized polymer. So it can vary up to from 210 GSM to 250 GSM. So sizing of envelope can be seen here. So when we size the envelope, we are having a very important term, which is known as the critical length of envelope. So as I mentioned at the time of static heaviness, the desirable thing we need is the lift minus weight should be equals to the payload. Okay. So when this condition fulfills, like lift will be equals to the total self weight, including the payload. When this condition occurs, so it will be the critical length of the airship. So generally we cannot get sufficient amount of lift less than the length of the critical length of the envelope. So when we have the length less than critical length, it will not be able to lift our payload up to the desired altitude. So that's why critical length of the envelope is very essential or very important. So envelope length of the airship should be adequate enough, and it should be greater than the critical length to lift the adequate amount of payload. So as we are at the end of this session, so we will continue this session in the after lunch. So before here, I would like to take some of your queries if you have any. So you can unmute yourself and ask your queries.
Yes, I want to ask a question that what types of motors we'll be using? So, like those in drones, brushless motors or something else?
Yeah, that can be used, but as per our thrust requirement, we can select out our electric motors.
Okay.
Yeah, can anyone have other doubts?
Not clear with tear strength.
Okay, so tear strength, when we have the envelope material, So it should not tear away. Like when it get hit by the wall or it get hit by any other equipments or any other equipments, and when we have some higher internal pressure, so it should not tear the envelope. Okay, so that's why the envelope material should have a higher tear strength. It should capable to take some loads before tearing up. That's why it should have higher tear strength.
Okay, sir.
I don't get the critical length point.
Yeah, critical length is the length of the airship at which the lift is equals to uh, the total self weight of the airship. So at which length of the airship, when we start our methodology, we guess a length, then we estimate the volume, then we proceed with the whole process. If we get the total system weight to be counted by the generated lift, so at that length is known as the critical length of the airship. So generally we should have higher length, higher than the critical length.
Okay, got it.